i-discuss for this MEtalino session will be about the psychrometric processes. So to start, uh, I will discuss sensible cooling and sensible heating. So sensible cooling of air is the process in which only the sensible heat of the air is removed so as to reduce its temperature and there is no change in the moisture content. So basically, sensible cooling is there is a reduction in temperature, nigamay ang temperature from T1 to temperature 2 and then constant ang moisture content, meaning constant CW from W1 and W2 equal sa duha. And then for sensible heating, on the other hand, sensible heating process, the temperature of air is increased without changing its moisture content. So I think this is one of the most basic, ay, basic nga psychrometric processes. So kani siya. So let's start with sensible cooling. Ano na siya. So um, basically, sa psychrometric chart, ang sensible cooling is represented by a horizontal line from kani siyang point 1 to point 2. So going to the left, 'di ba? So and then equal man si W1 and ang moisture content na to equal man W1 and W2, which is why ang kuan siya like horizontal line since in the psychrometric chart ang represent sa horizontal line is the moisture content, the vertical line is the temperature, the dry bulb temperature, horizontal line, I mean diagonal line at ipakita ang psychrometric chart. So, kani siya, no? So, this is our psychrometric chart. So, ang horizontal is the moisture content, W, and then kaning green nga line is enthalpy and the wet bulb temperature, wet bulb or saturation, wet bulb temperature, and the dew point diri sa kuan, diri sa 100% nga relative humidity, and then ang kaning violet or purple lines or curves kay the relative humidity and then napunta diri ang kaning broken line nga diagonal kay ang volume of dry air. So sensible cooling is kanang horizontal line lang siya na from this state to the next state. So next kay kana siya. So from the law of the conservation of mass to get the tons of refrigeration sa kuan sa sensible cooling process kay we from the law of conservation of energy and mass nga derivation. So Q is equal to mass of dry air times H1 minus H2 or MC delta T na na. So mao ra jud na ang for sensible cooling, and then for sensible heating kay bali na siya since from ang sensible cooling kay from right to left, ang sensible heating is from left to right. So kani siya ni-increase ang temperature. That's the main difference between sensible heating and sensible cooling. And then instead nga H1 minus H2 kay H2 minus H1 na ang sensible heating. So let's proceed kani siya. So cooling to the left and heating to the right. So let's proceed na lang sa first nga kuan, and I'll discuss the sample problems nga gi-discuss ni sir sa ato ang kuan, and then take home exam ata to ang for the second problem. So for sensible cooling, we have here outside air at 32 degrees dry bulb and 25 degrees Celsius wet bulb temperature flowing at 75,000 liters per minute is cooled using a 6-row DX cooling apparatus for ideal sensible cooling process. Air leaves the cooling apparatus at 90% saturation, and then we need to calculate the following based on the normal atmospheric pressure. So this is also important, guys, that we take note kung at atmospheric pressure bisya so that kay babata kung makagamit ta sa psychrometric chart or not, because the psychrometric chart only can only be used kung ang pressure na to is at atmospheric pressure. rather, sorry. So first na to pangitan is dry bulb temperature of air leaving the cooling apparatus. And then next, we need to find tons of refrigeration needed. And then sunod kay ang we need to plot the process on the psychrometric chart and label it completely. So the given DI is kani siya, dry bulb 1, temperature dry bulb temperature 1 which is 32 degrees Celsius, and wet bulb temperature 1 which is at 32 degrees Celsius ang dry bulb niya, 25 degrees wet bulb. Then we have volumetric flow rate of 75,000 liters per minute, and then natay relative humidity sa second which is kani siyang saturation 90 degrees saturation. So ang relative humidity at 0.2 is 90 degrees ay 90% rather. So atong pangitaon for dry bulb, we can find the dry bulb temperature using the psychrometric chart. For the tons of refrigeration, diri na ta mag-calculate, and then kani kay psychrometric chart ng gihapon. So first thing that we need to do kay ang 'di ba ang um, we need to locate the kuan kung asa siya ang point sa kani siya nga first state kung asa siya dapit sa chart. So using the two given nga naa nato which is kanang the dry bulb and the wet bulb, we can automatically locate asa dapit ang state 1. So kani siya vertical line man, di ba, ang dry bulb. So at 32 degrees Celsius ato i-draw siya dira, and then at 25 degrees wet bulb, so kung asa sila mo intersect, that is our state 1 sa ato ang problem. And then with this point kay makakuha na ta sa H1 since H1 is same line ra gyapon sa wet bulb, ato lang basahon ang kani diri nga reading. So ang H1 nato is 76.5, and then since na may mga deviations natay enthalpy deviation, so ato na we can read the enthalpy deviation using these yellow curves gani kaning kuan to kani siya. So kana ang mga HD na to. So ato na we need to subtract it from the value nga atong nakuha sa enthalpy. So since atong enthalpy is 76.5, and if ato i-read ang HD na to, i-estimate lang since this is kanang dili man siya ta ka-calculate ani. So ato i-estimate 0.2 and 0.4, and yeah, atong point kay nilay siya somewhere in between sa duha ka curves. So atong i-estimate nga around 0.3 ang HD nato. So subtracting the values nga atong nakuha from the chart, so we have our enthalpy at 0.1 which is at 76.2 kilojoules per kilogram dry air. So as stated po sa problem sa atong tons of refrigeration, kay we need to find the mass of the dry air nga nisulod sa system. To be able to get that, kay ang base atong given na amantay volumetric flow rate, so we need to find the specific volume specific volume of dry air based on the chart. So basa we need to kailangan natong kuhaon ang value sa specific volume. So specific volume at 0.1 kani siya, we need to magkuan lang gyapon ta. For example, itong 0.1, asa to akong tira. So this are 0.1 nga. Kani man atong line for specific volume. So mag-create lang gyapon ta og inana nga line same og slope. Oh no, di ukay ba mo ini? Sorry guys. Dara. So ato siya himuan og line inana ang kato ng laser akong gamiton. Dara. So magimo tag same anay nga line ito i-intersect sa point, and then kung unsa atong i-estimate nga ma-read in between ani nga values, mag-estimate ra gihapon ta. So mo na siya atong specific volume. So 0.89. So I think there are based sa giingon ni Ate Zar nako naay mga online nga psychrometric calculator wherein we can input the values of dry bulb and wet bulb, relative humidity, and dew point nga muhatag og values gani ani nila. So since dili man to nato siya pwede gamiton sa exam, wala ko sure kay ato lang ikuan estimate na atong kuan. So for kani for mga assignment siguro pwede to nato gamiton para makakuha ta directly sa value sa V1 na yung mga online calculators, psychometric calculators. So pwede ta mo kuha dito sa value sa atong moisture content, specific volume, enthalpy, and everything. So next, manaman ta og plot for state 1, so we need to plot for state 2. So state 2 kay ang given nato is 90% relative humidity, diba guys? And then since this is sensible cooling, it is understood that ang W1 na to is equal to W2, meaning straight line, as I said earlier. So, diretso na ta plot og straight line up until the 90% nga relative humidity, and kung asa sila mag-intersect, dira na atong point 2. And then, since na naman tayo, naka-plot naman ta og state 2 na to or point 2 na to, therefore, we can already get all the other values nga kailangan nato, such as the dry bulb temperature, the enthalpy, and the HD. And so atong enthalpy diri is 69 and atong HD is 0.05. So subtracting the two values, we get 68.95 kilojoules per kilogram dry air. And then for the dry bulb temperature, kani siya nga vertical line, it is estimated to be at 22 degrees Celsius. So atong dry bulb. So nanatay value for dry bulb, which is unsay gipangita for the letter A na to. So next kay atong pangitaon na lang is ang tons of refrigeration. So okay. So for the tons of refrigeration, kay first nato kuhaon kay ang we need to find the mass of dry air. So naman tay given nga volume flow rate of dry air, and ato sad gikuha ang specific volume of dry air sa chart. So ato lang i-convert ang volume of dry air to meter cube per second. So mo ni siya ang mga conversion. So 1,000 liter is equal to 1,000 liters is equal to 1 meter cube, and then 60 seconds is equal to 1 minute. So gamit lang taan ang conversion factors, and then divide nato sa specific volume, so 0.89 meter cube per kilogram dry air. So we calculate this one, nanatay mass of dry air, which is 1.41 kilogram dry air per second. And then gamit na ta sa formula. So since MA ay mass of dry air, nanataan ni nga value na nasa tay H1 and H2 based sa katong psychometric chart, and then ato lang i-substitute ang values, and then makakuha na ta og 2.9 tons of refrigeration. So convert pa sad from kilowatt to TOR, tons of refrigeration. So 1 TOR is equal to 3.516 kilowatt. So mora dyan siya for sensible heating. Next, we move on, sensible cooling, sorry. So next, we move on sa sensible heating. So same, the problem is, there are 500 cubic meter per minute of atmospheric air, initially at 25 degrees Celsius dry bulb temperature and 80% relative humidity, flowing through a steam heated coil. So after heating, the final temperature is increased by 10 degrees Celsius. So for ideal process, plot the process on the psychrometric chart and label completely the points. Determine the following: A, kay final air relative humidity; B, final specific humidity; and lastly, the heating required in kilowatts. So, mana siya itong problem atong given kay dry bulb at 0.1, which is 25 degrees Celsius, relative humidity at 0.1, which is 80%, and then atong volume flow rate, which is 500 meter cube per minute, cubic meter per minute, and then we have dry bulb temperature at 35 degrees Celsius, because increase man daw by 10 degrees Celsius, so 25 plus 10, so we get 35 degrees Celsius. So for this one, relative humidity and the specific humidity, we can plot this gapon sa psychrometric chart. And then for the heating required, kay gamiton to nato ang formula nga gi-state a while ago. So Q is equal to mass of dry air times H2 minus H1. So also important, noting that atmospheric air siya, so P is equal to 1 atmosphere or 101.3 to 5 kilopascals. So for the properties, ang given nato diri is, diba, dry bulb and relative humidity at 80%. So muna itong gamiton uh, to plot our first point sa curve na to. I mean, first point or state 1 na to. So, mo ni siya ang 25 degrees nga 25 degrees Celsius sa dry bulb temperature, and then our relative humidity at 80%. Kani siya nga curve, this is 80%. So at intersection nila, so which is dire nga point, automatically mo na tong point 1. Sorry dai guys, nabali siya. So mo ni ang point 1, mo ni ang point 2. And then since na naman tayo point, nakaplot naman tayo sa point, we can get the values of enthalpy, which is 65.9, and then estimated, and then ang HD nato is around niigo kani siya HD, niigo jud siya sa mura siya niigo sa 0.1 kilo. So ato i-subtract 65.9 minus 0.1. So atong H1 is 65.8 kilojoule per kilogram dry air. And then since we also need the mass of dry air again for kuan sa ato ang heat, to get the heating required, the value of the heat required. So we also need to get the specific volume. So again, specific volume of um, kani siya at I think sayop gihapon, sorry kaayo. So specific volume at point 1 is 0.87. I same red ay guys. And then 0.87 kani siya ang value, and then next we need to plot point 2. 1 point 1 point 2. Ano ni akong mouse? Basta guys, point 1 ni og point 2 ang kani ang point 1, kani ang point 2. Okay, so at point 2, since again sensible heating is kanang a constant moisture content ka process. So straight horizontal line gihapon siya. So we have mag-plot lang ta og straight horizontal line, and then we intersect it with the value that we have for point 2, which is sa to atong value for point 2, which is ang dry bulb temperature niya, which is at 35 degrees Celsius. So mag-plot ta og 35 degrees Celsius nga dry bulb, which is a straight line niya, intersect na to sa ato ang kaning horizontal line. So maka-plot na ta og state 2 na to. So state 2. And then we also need to get the values na pod for enthalpy. So H2 kay 76.3 minus HD, enthalpy deviation at 0.44 as approximately. And then so we subtract the values, we get 75.86 kilojoule per kilogram dry air. And then with this plot na to, katong pag sa atong point, with this point kay we can get also the relative humidity at point 2. So kani siya nga curve, kaning dark blue nga curve, which is estimated to be at 45%, kay in between man siya sa 40% o 50% nga relative humidity. So it is estimated to be at 45%. And then atong basahon ang value sa moisture content, which is kaning horizontal line. So W1 is equal to W2. So W2 na to the specific humidity of air at point 1 and point 2 is 0.016 kilogram water per kilogram dry air. And again, first to get the heating required in kilowatt, we need to find the mass of dry air. Given na nanatay nakuha nga value sa kaning H2 ug H1. So, um, mass of dry air is volume divided by specific volume. Volume flow rate divided by specific volume. So we have 500 meter cube per minute. So convert that to meter cube per second, and then divide the specific volume, and then we get 99.58 kilogram dry air per second. And then we substitute the values that we got from the kaninga calculation o gikan sa psychrometric chart nato nga um, calculations pod katong H minus HD. So we get 96.37 kilowatts. And that would be all for sensible heating and sensible cooling. Thank you.
Humidification, the humid, may sunod sa?
Yes. Thank you, Dedes.
So, may naray nakita, guys.
Nara. Narasan.
So, so the next concept na I will be talking is about humidification and dehumidification. So, basically, humidification refers to the process of adding moisture, water vapor, or humidity to the air, and the humidifier is a common device used in this operation. On the other hand, dehumidification is the opposite of humidification. It is basically the term implying that so as the term implies, the humidification includes the removing of moisture from air, and a dehumidifier is a common device used in this operation. So in a psychometric context, humidification refers to the an increase in the specific enthalpy, a specific humidity rather, without the change in the dry-bulb temperature, while the dehumidification is the decrease of the specific humidity without the change of the dry-bulb temperature. So sa katong mga notes ni Sir kay wala man ko'y nakit-an nga problem solving pertaining humidification and dehumidification only. So diretso lang ko sa relationship sa mga psychrometric properties in humidification and dehumidification. So ari ko sa SolidWorks drawing. So as I said earlier, humidification is this increase of the specific enthalpy, which is kaning apart sa chart without the change of the dry-bulb temperature. So it is plotted in the psychrometric chart in a vertical line. So like this, ana siya. So humidification, drawingan na ko arrow, the triangle ako drawing siya. So it's humidification. So that is baba here. Here is the point 2 and the state 1. So 1 and 2. So to make sure nga sakto jud tong ako isa to nga there is an increase in the specific humidity in a humidification process. When it plotted in the chart, so specific humidity kay horizontal line. It is kanina horizontal. So sa kaninga part, this is the specific enthalpy sa state 1. And so during a part is the specific humidity sa state 2. If you read it in the psychrometric chart, so for instance, ang kaning humidification specific humidity sa point 1 is 0.004 kilograms of water per kilogram of dry air, and point 2 is assumed it is 0.0245. So therefore assume 0.5 kilograms grams of water per kilogram of the air. So therefore, since mas dako man ang specific humidity sa kani sa point 2 than rod 1, therefore sakto tong giingon nga ang sa humidification is a sudden increase an increase rather in the specific humidity without the change in the dry bulb temperature. So the next property atong is we observe is the what kaning enthalpy. So enthalpy. Enthalpy is graphed in the sacramental chart like just like this and in diagonal nga na like na siya. So basically ang graph sa specific enthalpy and the wet bulb temperature are the same, but ang nakalahi lang is ang sa specific enthalpy kay kani siya kani dapit na nag-circle na kani siya dapit kani kung nag-line siya. But sa wet bulb temperature ang imong readings is kaning kaning 925 30 20 kani sila kaning here na so upon reading sa kaning sa econometric chart, so ang sa state 1 is yung enthalpy is assume lang ito it's 58.9 something 58.9 sa state 1, but in the state 2 yung enthalpy reading is 100.9. So observe sa nimo is nasa babaw sa diyang reading, then sa state 1 is nasubos. So ang specific enthalpy sa humidification is increasing. And also the same sa wet bulb temperature since same raman sila graphical representation. Then the next property na atong i-observe is the dew point temperature. So basically ang dew point temperature o ang specific humidity is same sila og graphical representation with this the horizontal line. So ana siya. So pero ang sa pagbasa sa temperature kay same ra sila og kaning numerical naka wet bulb kay kanira gyapon numbers kaning mga temperature. So napa ko sa sud.
Napa ni choppy ka.
Nilag
Mm.
nilag kong kalit. Hala nilag ko palayan nila. So upon reading in the stoichiometric chart, the dew point temperature in state 1 is assumed to for assumption is 0 degrees Celsius, and in state 2 is reading is kani 25, 26, 28 point something. So since basta ko ang dew point sa state 2 than state 1, therefore the dew point temperature in a humidification has a increasing in humidification, the dew point temperature is increasing. And so the next property na atong studyhan is the specific volume. So the specific volume is graphed is represented graphically like this. Ito siya. And also sa state 2. So psychrometric chart, you can see the values of the kaning specific volumes kaning diagonal lines nga broken. So kung circulan sa kani siya. Ay, ano na siya? Siya. Kani kadilupit kani. Kana siya. Mana siya ang sa specific volume. So upon reading sa psychrometric chart, so sa state 1, yung specific volume is 0.90, so 91, 91 cubic meters per kilogram of dry air. And the state 2 is almost 0.85 also. Assume is 0.945 cubic meters per kilogram of dry air. So since the specific volume of state 2 is bigger than the specific volume of state 1, so therefore the relationship of the specific volume and the humidification is their proportional. So sa humidification process, ang specific volume is increasing. So lastly, atong studyhan nga what they call this psychrometric property that we will be observing is the relative humidity. So the relative humidity is represented graphically but like this. Siya. Siya. So kaning violet lines, which is one na siya ang specific relative humidity rather. So bring us that. So upon reading the psychrometric chart, we can see that the relative humidity at state 1 is less than 10%. So let's just assume that it is 6%. And the relative humidity at state 2, which is state 2 is between 30% and 40%. So assume is 35%. So since upon reading, so mas dako ang relative humidity sa state 2 compared to state 1. So therefore, ang relative humidity sa humidification is also increasing. So therefore, tanan psychrometric properties except the dry bulb temperature are increasing in humidification. Kaya ang sa dry bulb temperature kay constant sa humidification rather is constant ang dry bulb temperature. So when it comes to dehumidification, it is just the opposite sa humidification. So kung sa humidification, increasing tanan, so dehumidification is decreasing tanan. So I think that's all for the humidification and dehumidification. So that's it. Thank you.
Thank you, Vincent. So before we proceed to the next next process, psychrometric process, are there any questions or clarifications about sensible cooling, sensible heating, humidification, and dehumidification? Wala na, guys. Wala na, Mel.
Ay katong na ako'y question sa katokang sa sensible cooling and sensible heating. Katong pwede na ba sa sensible heating and cooling kay temperature ang gamiton instead of enthalpy? Kay katong na-mention ni Desa kay asa ganito sa katong enthalpy ang isa gigamit then isa kay temperature. Dili pwede ang duha kay temperature difference lang. Yeah, kung asa ang mas dako kay mo siya punto ang may kuan.
Katong equation nga MC delta T mel,
Yes,
pwede na to gamiton
ang kanang pwede ra temperature in terms of temperature lang ang sensible heating ug cooling.
joke, sorry na wala day ko na kuan. So, kuan well no, temperature ang gamiton, temperature difference times mass of
Oh,
dry
yeah.
air. Oo, and then ang kuan man sad ang CP ni air kay at 1 naman ang giingon ni sir. So,
Ah,
pwede ra.
so, kuan sa regardless sa kung heating siya o cooling, pwede ra in terms of kanang temperature.
Mm.
So,
Nasa
kay katong sa example sa kay kuan to sa cooling to kay imong ang gigamit kay ang enthalpy ba to?
sa enthalpy.
Thank you sa
Sige, Mel.
No, may other concerns, guys? Questions? I hear none. Char, what was Madam Chair? Wait. So, wala na yung question, guys.
Maro to
yun
ako
na.
asar.
Sige, thank you, Mel. So, move on ta for kuan. Basta nakita si Messenger. On ta for temperature and humidity change. So, nakita lang ang screen, guys.
Yes, sir.
Yes, thank you, Mel. So, now move on to the session 8 or ikatulong nga psychrometric process, which is the combination of sensible heating, sensible cooling, humidification, and dehumidification. So, it is the temperature and humidity change. So, temperature, we pertain to the sensible cooling and sensible heating, and the humidity change, we refer to humidification and dehumidification. So, for this process, Kate, is the combination of both. So first, I will discuss about cooling and dehumidification and heating and humidification. So first, about cooling and dehumidification. So as what Dasa and Vincent discussed earlier, so cooling is the extraction of heat in which the dry bulb temperature decreases, and dehumidification is the extraction of moisture from the air, which is there is a decrease of specific humidity or humidity ratio. So this is applicable to hot and humid climates such as here in the Philippines. So our air conditioning system are usually of cooling and dehumidification. So dito ta sa sample problem. So the problem states that the outside air at 32 degrees dry bulb and 25 watt bulb temperature flowing at 75,000 liters per minute is cooled using 6-row DX cooling apparatus with apparatus dew point of 20 degrees Celsius. For ideal cooling process, air leaves the cooling apparatus at temperature equal to its apparatus dew point. So take note of this sentence nga if idea gani ang cooling process kay ang air mo leaves at it leaves the cooling apparatus at temperature equal to its apparatus dew point. So meaning the dry bulb temperature at final is equal to the apparatus dew point temperature. And to continue, if barometer pressure is 1 atmosphere or standard atmospheric pressure of 101.325 kilopascals, we are to calculate the tons of refrigeration needed or the Qref nga need ang heat nga atong need i-reject sa system and plot the process on the psychrometric chart and label it completely. So to investigate the question, we are to kanang list the given so that we will be guided on what are the variables or the parameters that are presented in the problem. So the outside air is given with dry bulb temperature of 32 degrees Celsius and wet bulb temperature of 25 degrees Celsius. And the outside air is flowing at 75,000 LPM. And for the apparatus dew point, it is 20 degrees Celsius, and as well as the dry bulb temperature of the air at final after the process is also 20 degrees Celsius. And also our barometric pressure is 101.325 kilopascal. And we are asked to plot the process on the psychrometric chart and the tons of refrigeration needed. So, so first 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 of all, okay, kanang we before we solve the equation mathematically, we are to um study the psychrometric chart. Study the process through the psychrometric chart. No, so through the given sa problem kay we are to plot we are to plot the kanang values. So first, the outside air is at dry bulb temperature of 32 degrees Celsius, so represented by the vertical line, and also the wet bulb temperature of 25 degrees Celsius, so presented by these lines. So ang intersection ani, as what Vincent kanang explained earlier, nga nag-explain na si Vincent sa about the properties in the psychrometric chart. So ang intersection ani is what is the first state sa or first property or first kanang condition sa atong air at 1. First condition sa redundant. So first condition sa air. So next is the final condition sa air, which is equal to the apparatus dew point temperature, which is 25 degrees Celsius. And ang automatic na siya if apparatus dew point is igo na siya dito sa sa 100% nga relative humidity. So we are safe to assume nga ang kaning air is already at saturated or saturation condition. So to plot the process, so mo ni atong second condition sa air. Then to plot the process, undergo siya og cooling, and then the dehumidification process as what it is described nga ni-decrease ang iyang temperature from 32 to 25 and ni-decrease ang iyang specific humidity ratio from 1 to 2. So ano yun si sir nga, pwede, dili necessary nga una si cooling, then si dehumidification. So, pwede siya simultaneous. So, it is represented by this line, kaning diagonal line inclined to the left and pointing down. So yes. And then after plotting it the psychrometric chart, we can determine the properties agad-agad, no? So that we can already solve what is asked in the problem. So for the properties, it is very important to get the enthalpy, the specific humidity, and the specific volume for the state 1 of air. So kanang wait, mag-laser ta. For the first condition sa air, so we plot the H1, the enthalpy, the specific humidity, and the specific volume. So it is given or it is found out that these properties are 76.02 kilogram per kilogram of kilojoules per kilogram of water. So kanang the finding the enthalpy is very crucial when magamit yung taog psychrometric chart, no, because kanang nilahi ugog ka ng estimations ba kada taon na since it kanang mag-deal jud siya og katong deviation. So kon lang jud kanang i-indicate lang jud kung pila ang deviation, and take note lang nga if toward na gani or if lapas na gani kani diri sa left kaning 0.05 na kani diri nga part kay kakon na assume na nga ang deviation is 0. So 0.05 ang ni diri kay kon lang ta mag-deviate ta sa enthalpy. And then corresponding specific humidity 0.171, and kanang estimated nga volume, specific volume is 0.89. And while sa kaning second condition sa air is again find the enthalpy and then the specific humidity sa air. So and then we can already solve for the given. So first kay mag-study ta sa specific schematic diagram sa cooling and dehumidification process. So we have here the kanang cooling coil, and then as air passes through the cooling coil kay mukuan siya mo create siya og condensate. Kay remember what sir discussed nga if ang air is the temperature of the air is greater than the temperature sa coil, meaning na-condensate sa or na-dripping, while if mas greater ang temperature sa coil kaysa sa temperature sa air, kay wala dripping nga mahitabo. So mo na since our air is greater than the EDP kay siya expected nga na-condensate. So mo na na-condensate diri nga nigawas na at kanang with enthalpy of fusion. And then nimugawa si air ani mugawas si air at second condition nga kuan siya, cooled and dehumidified. And then ay mugawas ng QREF diri in which kanang heat is extracted from the cooling process. So muna you have to um, based on the law of conservation of energy, mass in and energy in and equals energy out. And then we derive with this equation nga QREF equals MA times H1 minus H2 minus the mass flow rate of the condensate times the enthalpy of fusion. Sakto ba? Enthalpy fusion? Sa kana. And then we and kana and kuan sa technique sad kay para diso to sa problem kay we investigate the equation if unsay mga values nga naa na and unsay values nga wala. So we have already our H1 and H2 and our HF kay bitsura na siya sa steam tables. So we have to solve for the mass flow rate of dry air and the mass flow rate of the condensate. So to solve for the mass flow rate of the condensate kay we are to obey again the law of conservation of mass. So presented here, mass in, mass out, and then we derive with the mass flow rate of the condensate minus equals MA times W1 minus W2. So I hope nakasunod ra. And then kuan din ta, mag-solve din ta for the mass flow rate of dry air and the mass flow rate of the condensate. So the mass flow rate of dry air is shown by the equation as volume flow rate of dry air over the specific volume of dry air. So substitute and gonna play with the units, no? So liters, minutes, and then we are left with kilogram of dry air per second, and then we are get the nakakuha na ta sa mass flow rate of dry air of 1.41 kilogram of dry air per second. And then okay na si mass flow rate of dry air, so nabili na lang kay si mass flow rate of condensate. So we are going to use the equation and then again substitute the values and play with the units so that we will be guided with the kung sakto ba jud ang formula nga atong gigamit and sakto sad ang parameter nga atong pangita. So cancel si kilogram of dry air. So and then we're left with kilogram of water per second. So makabawta nga la si condensate jud atong gikuha. So si condensate is in liquid form man. So sakto ra nga. So muna ang mogawa sa di kay kanang 0.00 something. So ato i-convert to grams of water per second so that kon siya dili siya kanang practical siya ba dili siya kanang ma-imagine na dayon nato nga mo ni ang or ang mass flow rate ni condensate. So next, okay na ta. So we can find na the tons of refrigeration sa system. So again, then katong enthalpy of fusion from steam table. So we are going to base it with the kanang ADP. So HF at 20 degrees Celsius, so we have 83.86 kilojoules per kilogram of water. So finally, we can get or solve the equation to get the tons of refrigeration needed. Again, substitute and play with the units, and then we can get the TOR of 7.53. So wala rin questions, I guess. May nasabtan ra. So,
Nakoy
man.
questions are, what
Naman
if
nal.
kanang dili siya ideal process ang D-state, ma-identify ba na nato? Kay katong ka nga dili din equal siya sa ang final to kanang ADP. Possible ba siya?
Kuan. If dili siya ideal sa
Like
wala
kanang
mo
dili
lagi
siya
discuss.
state ba? So maybe ideal guro sa always.
Oh, I think kuan kanang automatic siya nga ideal. Okay.
Og kaning HFC sir ba ang C ani kay condensate? Thank you.
Condensate. Okay na. Sorry for not clarifying again. Muna, Sa kung na-recall sad kay wala sad kayo nag-discuss si sir o dili ideal.
So kung dili ma-mention nga ideal process kay maybe kuan din na siya sa assume nga ideal.
Oo, same sa katong take-home exam, katong same ra ani niya. Wala man to ningon nga ideal. Ako rang gi-assume nga ang katong dry bulb sa air at second kay same sa katong EDP.
Sige,
Moro.
sige. Thank you, Zar.
Pero para man sa nino kanang multiple choice may buwan na sa sakto atong pan. Sakto atong assumption.
Assumptions.
Sige, go. Kuan. Sige, move on to the second type, which is the heating and humidification. So opposite sa cooling and dehumidification, heating is kanang increase of temperature and increase of specific humidity. So ni absorb og heat and ni absorb sad og moisture. So for the problem kay winter air is heated and humidified through steam, heated coil, and humidified using water sprayer. So humidification involves two elements, which is steam and water sprayer. So for this problem, kay water sprayer ang ni involves the problem. So air is flowing at a rate of 750 cubic meter per minute, and winter air is initially at 10 degrees Celsius dry bulb and 90% RH. So the final condition of air after the process is 24 degrees dry bulb and 60% RH. So consider at normal atmospheric pressure and determine the rate of water injection in the sprayer per second with water temperature of 30 degrees Celsius and heating needed in kilowatts. So we are asked to about the rate of water injection the sprayer per second with a given water temperature. So this pertains to the mass flow rate of the water na ni-spray para mo humidify sa air. And also the heating needed in kilowatts. So to move on, again, kanang study the problem through the psychrometric chart. So we are given with initial condition of our air at 10 degrees Celsius and 90%. And the second condition of our air at 24 degrees Celsius at 60% relative humidity. So process is described this way na kanang opposite sa cooling and dehumidification nga padung ubos and left. So ang heating and humidification is padung babaw and right. So on and identify the properties. So same gihapon for the kung gihapon enthalpy, specific humidity and volume flow rate sa first condition sa air. And then sa second condition is sa air kay dili ra need ang volume specific volume sa air. So mo na sa first state kay 28 kilojoules per kilogram of dry air. So di pa na zero ang deviation ani while sa H2 is you need to consider the deviation sa enthalpy. So same gyapon nga specific humidity is kaning horizontal line and the kanang specific volume is kaning curve. And then now move on again, study schematic diagram so that we can derive the equation nga kanang unsay governing equations. So the law of conservation of mass, since we are to get the rate of the water sprayer. So again, mass in and mass out, and then we derive with this equation for A, mass flow rate of the water equals mass flow rate of dry air times W minus W1. And again, law of conservation of energy, energy in equals energy out. So again, we derive with this governing equation for B. So, move si Mel. Ana. I hope nakasunod ra and mga bright na sa ni mga nadiri so pira na. So again, kan gyapon investigate the equation na for this governing equation for A, we have already the W's and wala tayo mass flow rate sa air. And for the governing equation for B, kay makaget ta ni mass flow rate ni dry air, and then nanatay enthalpy, and then solve pa ta ni MW, and kuha na to si HF sa steam table. So malahos na ta. And kato mass flow rate of dry air gihapon specific flow rate over specific volume, and then inject or substitute the values and play with the units, and then we derive with mass flow rate of dry air at 15.43 kilogram of dry air per second. And then
Hmm?
finally we can get the rate
Dalawa.
of water injection of
Dalawa.
mass rate of dry air mass rate of dry air per I times the W2 minus W1. And again, substitute the values and play with the units, and then we derive with 61.7 grams of water per second. So, mo ni ang amount sa water injection nga need para ma-humidify si air to achieve the um kanang katong unsa nga condition sa air ang dapat ma-achieve kato. And then finally, we can get the heating needed in kilowatts based sa katong equation. But before that, we get the condensate enthalpy of fusion from steam tables. So, at 30 degrees Celsius. So, katong given sa problem sa temperature sa water. And then we get with 125.75 kilojoules per kilogram of water. And the heating needed to achieve the final condition of the air, again, substitute the equation, the values, and play with the units. And then we derive with 375.21 kilowatts, which is the heat needed to achieve the final condition of the air based sa problem. Nakalimut ko kato. Based sa problem. So, that will be all for the third psychometric process. So, I hope na sabtan ra sa tanan. Sabot ra mo tanan, uy. So, if you have questions, kay ato lang na i-discuss. If
Ako na
wala
yung kuan.
kay, if wala na kay, move on na ta sa part ni Oro.
So, good afternoon everyone. So, ang kuan day ani ang flow sa ako kay mag-discuss ko kadiyot sa basics of adiabatic mixing, then after ana kay na yung sample problem. Ay, wait, madungog ba ang audio? Kay basig nag-play ra ba?
Tungog ra
Kaya
Oro.
oh, sorry.
Pwede mo ask, nanay audio?
Wala, di madungog?
Wala ko nadunggan karon.
Oh,
Imo
so,
ra tingog
Ay,
ka lang.
nag-play ang video? Or wala? Ay, nay,
nag-play,
nag-video?
nag-rec,
Ay, wala
nagkuha mo
eh.
kog. Wala di madungog di balik ko na.
Ay, bilang ka na storya.
Di nag-record ko daan kay nagamit mo og stylus niya. Usa ra may
Ah,
saksakanan ako kan.
sanong cool. Kuan daw, share audio daw.
Murag wala din ako na share ang audio. Sige, salamat sa pag-inform. Good afternoon everyone. I will be discussing about the adiabatic mixing for this Metalino session. I am Roy Christian P. Oro and here it goes. So, what is adiabatic mixing? So, it is the mixing of two or more air streams. The heat transfer with the surroundings is usually small, and thus the mixing process can be assumed to be adiabatic. So, due to the insulation, the heat transfer from the inside of the ducts to the environment or ambient air is very small, which is why it is assumed to be adiabatic. So, what does it mean if a process is adiabatic? So, in an adiabatic process, there is no heat that enters or leaves the system. So, heat is signified by the letter Q. And if we take a look at the schematic diagram of an adiabatic mixing process, we see the system which has a boundaries shown by the dashed lines which I am tracing right now. And as you can see, there is no Q, no heat going in nor going out the system. So this is the system inside. And in comparison, if we take a look at the cooling and dehumidification process, if there is still the system and its boundary is shown by the blue dashing lines or dash lines, and as you can see, there is Q, which means that in the cooling and dehumidification process, there is heat going outside or away or leaves the system. So that's one of the main differentiators when considering an adiabatic mixing process. So now let's try to analyze what a adiabatic mixing process looks like on a psychrometric chart. So this is the diagram, and as you can see, 1 and 2 are the inputs while 3 is the output. And generally, you will know the properties of the input, so state 1 and state 2, but the properties of state 3 is unknown. And if we plot it, you can see that here this is state 1 and here there is state 2. And as you can see, state 3 is found on the same line that connects 1 and 2. So that's the first observation. Under adiabatic mixing of two air streams at different states, namely 1 and 2, state 3 or the output lies on the straight line connecting 1 and 2. And then if we take a look at it again, so if state 3 is found anywhere within this line, so how will we know if it's close to 2 or if it's close to state 1? So the way to know it is to show or to know the mass flow rates of state 1 and the mass flow rate of state 2. So how close state 3 is to states 1 and 2 depend on their mass flow rates, symbolized by MA1 and MA2. If the mass flow rate of state 1 is greater than that of state 2, then state 3 is close to state 1. So if mas dako daw ang kaning mass flow rate of state 1, ang 3 kay mas duol niya. So pwede diri or basin duol jud kayo. So that's the point. Now, the second is if the mass flow rate of state 1 is less than the mass flow rate of state 2, then state 3 is now closer to state 2. So in this case, diri na siya, duol-duol siya sa state 2. Lastly, if the mass flow rates of the two states are equal, then state 3 is at the middle. So that's what we can see here. Murag na siya sa tunga. So if we take a look at the adiabatic mixing process now on a Carrier psychrometric chart, since state 3 lies on the straight line, so that connects 1 and 2, only one psychrometric property is required to plot it. So again, only one psychrometric property is required. And what are these properties? So we have the dry bulb temperature, wet bulb temperature, dew point temperature, specific humidity, relative humidity, specific enthalpy, and lastly, the specific volume. So what does this mean? So when you are solving for the properties of state 3, of course, to get all its properties that are necessary, you must be able to plot it on the chart. So let's say you apakakibaw asa ang state 3 ani, like naba siya diri, or naba siya dire. So how will we know that? You just need to find one of those properties. So let's say I was able to solve the dry bulb temperature at state 3, and I know that it is this red line. So from that, now I know the specific humidity, W. I also know the enthalpy now because it's the diagonal line. The same would also happen if you were able to get the specific humidity or W of state 3. So it's just a matter of finding one of those. So now the question is, how do we get one of those properties that we want? And that is through equations or problem solving. So when considering a diabatic mixing, there are four equations that we have to know. So the first equation is just a mass balance of dry air. And mass balance is shown by a summation of the mass going in, sigma mass in, and it must be equal to the summation of mass going out the system. So for this case, we will only be focusing on dry air. So if we take a look at the schematic diagram over here, we can see that there is two dry air going in at state 1 and at state 2, and there's also only one going out, which is at state 3. Hence this equation. Now let's take a look at the second equation. The second equation is just the same mass balance principle. However, we are now focusing on the water vapor or water in any form. So in this case, we only have to consider the water vapor since unlike cooling and dehumidification process na magtuto man to siya, so i-consider sa tunay mo ang tubig sa nga nagtuto. However, dire we'll just consider the water vapor in air. So we know that the mass of water vapor in air is given by, so this is the water, is equal to the mass of dry air times the specific humidity. So, and given that equation, we can use that to get the mass balance. So mass of dry air at state 1 multiplied by the specific humidity at state 1, and same for state 2 since those two are the inputs, and the output is the water vapor at state 3. Hence this equation. Okay, now let's move to the third one. And for the third one, it is not a mass balance anymore. Instead, it is a energy balance. So if you remember, the energy balance is similar to the mass balance. However, it only considers the summation of energy going in, and it must be equal to the energy going out, or the sum of those energies. So if we take a look at this schematic diagram again, there is no Q, there is no W going in or out. And we also consider kinetic energy and potential energy to be zero. So if we write that down, Q equals W work equals potential energy equals kinetic energy, which is equal to zero. So if you take a look at the energy going in, it's gonna be just the enthalpies now. So mass of dry air at state 1 times the specific enthalpy at state 1, and the same for state 2, and it must be equal to the output. So and that is how we get this equation. Now what about the last one? So actually that equation cannot be found in most textbooks. And why? It's because that equation is just derived from the energy balance. And what do I mean by it? So we know that the enthalpy is equal to the specific heat times the delta T. So if we break that down, it becomes Cp and the dry bulb temperature minus the reference temperature. Usually, this reference temperature is just 0 degrees Celsius, which means that the equation just becomes Cp and the dry bulb temperature at that enthalpy. And if we use this equation in this equation, so we substitute the values of specific enthalpy, we will get that MA1 times CP TDB1, and the same goes for the other states. CP TDB2 equals MA3 Cp TdB3. So although the specific heat varies according to the temperature, we will consider that equal. So which is why we can just cancel. So cancel, cancel, and cancel. This will leave us an equation of Ma1 TdB1 plus Ma2 TdB2 equals Ma3 TdB3, which is this equation. So let's apply what we have learned through a sample problem. So a stream of 2 meter cube per second of outside air at 4 degrees Celsius dry bulb temperature and 2 degrees Celsius thermodynamic wet bulb temperature is adiabatically mixed with 6.25 meter cube per second of recirculated air at 25 degrees dry bulb temperature and 50% relative humidity. What is the dry bulb temperature and wet bulb temperature of the mixture? So that's after the mixing. Afterwards, the mixture is heated sensibly, sensible heating, under ideal conditions. To maintain the same temperature as the recirculated air, so that's your TdB4, how much heating is required? So from the problem, we can get the given. So that's the specific volume. This is the dry bulb temperature, wet bulb. So take note, relative humidity ang given sa ikaduha. So now the question is, what does this mean? So same temperature as the recirculated air. So meaning ana, ang imuhang dry bulb temperature after heating, so state 4 after heating, it must be equal to the temperature sa recirculated air, which is at state 2. So this must be equal to 25 degrees Celsius. So now, so akong i-discuss giun sa ako pagkuha sa psychrometric chart, pero before that na may questions. I think wala raman. So
Wala pa.
So akong gamit para sa yun i-plot sa psychrometric chart kay magotokad lang ko. So we know nga kibaw ta sa states 1 and 2 since given man to ang at least duha sa ilang properties, di ba? So let's start with state 1. So ang kuan ra di ani guys kaning mga lines ani kay ako ra ni giandam daan para din ako mag draw og line. So kani kay morning vertical line to represent the temperature, then kaning cyan is to represent the specific volume. Ang kaning light green is to represent the wet bulb temperature and the enthalpy at saturation. Then the blue line is to show the specific humidity, tong W. Then ang black kay mo na ang process jud. Sige, so we know that at state 1, it's at 4 degrees Celsius dry bulb. So i-move na to siya at 4 degrees Celsius dry bulb. So mo sa ni rasod nga ganahan ko nga usually ang buhaton man basta na take home exam kay akong himuon daan sa AutoCAD niya i-print na nako niya ako i-kuan ba i-ballpen para di na labad sa o. So kani 4 degrees Celsius ang wet bulb. So sakto mangguro 4 degrees Celsius. The next is we need to get the atong i-plot kay ang 2 degrees Celsius nga wet bulb. So kung wet bulb gani ang kuan ang gihatag, so tan-aw nimo kani nga mga temperatures kani -5, 0, 5, 10. So 2 degrees Celsius, so 0, 1, 2. So this is your 2 degrees Celsius wet bulb. So now hibaw na nato asang state 1. And para sa yun nato na lang ni move. So copy, move. And now we know the values for the state 1. State 1. So giandam na ako daan. Move. So now nanatay state 1. So the next thing is of course to find state 2. So state 2 is at 25 degrees Celsius dry bulb. So atong magkuha sa tag red line 25. So here 25 25. And then it has a relative humidity of 50%. So ang kaning relative humidity is kaning violet nga lines nga padong curve taas. So kani siya. So pangitaw na to 50 and here is the 50% line. So ato i-connect sa katong giporma na to nga vertical line which is this one. Then nakalimot ko. Wala man ni murag curve nga line akong duman diri. So ako draw lang tag gamay nga linya. So now kibaw na sa taas ang state 2. So the next thing is just to move these kanakuan mga lines. So copy and then so now we know the two states. Yeah, ang kuan na lang ni pagkuha na lang sa or pag-read na lang sa values. Now, I'd like to preface this by saying nga kanang usually akong buhaton kay aside from the specific volume ang tanan kay gikan jud na sa chart pero ang specific volume kay mag-agad ra jud ko sa kanang online nga mga calculators or charts kay lisod kay kuan good kay laylay ang distance ba sa kaning specific volume. So maglisod ka kanang estimate. Sige, so now unsa may kadalasan kuwao nako or kailangan sa pag-solve sa adiabatic mixing. So usually tulo ra na sila. The first is the enthalpy, specific enthalpy. Then the second one is wait na mo ko gipander. So giandaw ni nahodaan para dili masayop. So usually mo ra jud ang kuwao naho ang specific volume, ang specific humidity, and lastly the specific enthalpy. So ang specific volume kuwaon na nimo if given ang katong volume flow rate which is mao ang case sa sample problem. So mo nang kuwaon nato ang specific volume. Pero if given na gidaan ang mass flow rate same sa katong number 3 sa take home exam 10, so diretso na lang ay na lang kuha ang specific volume. So itong kuwaon ng values. So let's try getting first the specific except lang sa specific volume kay murag gibana-bana ra man ko ni like kani kay duol sa 0.8 so 0.79 something like that. Yeah, same pod sa kani diri duol siya sa 0.85 so ako ra gi plus 0.01 so 0.86. And then so let's just get the specific humidity. So ang kuan ani niya is ang gamay nga mga marks ani ang graduation is 0.0002. So kani siya kay 0.0032, 0.0034, then kani siya is 0.0036. That is our W1. And for our W2, so tunga-tunga man siya sa kuan sa kani ug kani. So 0.9 na siya. So 0.0099. So it's the same as the one I've written here. 0.0099 for W2 and 0.0036 for W1. Now, ang sa pag-solve sa enthalpy using the Carrier chart, we must first get the enthalpy at saturation. So mo ni kani diri. And then i-minus nato ana ang kaning enthalpy deviation which is kaning mga orange nga linya. So kaning mga enthalpy deviation man ni kay. Ang rason man ana is if you take a look at the ASHRAE charts, dili jud magtugma ang linya sa enthalpy nga lines ug ang sa wet bulb. Pero since labad man sa O kay daghan pa kay linya giusa na lang sa Carrier nga charts. And to make up for the inaccuracy nga giusa ang linya, mo na kailangan nimo minusan ang enthalpy deviation. So let's go for the first lang sa state 1. So unsa may HSAT, enthalpy at saturation. So for state 1 is kani siya diri. And that is 10, 11, 12, 13 kilojoules per kilogram. And then if we take a look, wala may duol nga kuan nga katong enthalpy deviation line. So minus 0 ra siya. So again, 13 kilojoules per kilogram minus 0 which is what we have on the this one over here. So 13 kilojoules per kilogram. Now let's go to the second one. So for the second one, ang yahang enthalpy at saturation is this one. So pila man na siya? So 50 ang dako, 0.5 ang gamay, so it's 50.5. Then i-minus na to ang enthalpy deviation which is since dool man siya sa 0.2, I guess I assumed it as minus 0.3. So it's 50.5 minus 0.3 or 0.2. O yeah, gi-minus na dyan ako 0.2. So wala ko gi-increase, so dool man siya sa 0.2, 0.2 na lang nako. And that's how we get specific enthalpy of 50.3. And using those values, maka-proceed na ta sa solving. So, balik ta sa here. So now, we can solve for the other values. So, first thing we have to do is to get the mass flow rates, since ang given man nato kay volume flow rate, so volume flow rate of state 1 and then the volume flow rate of state 2. And we know that we can get it because the mass flow rate is equal to the volume flow rate divided by the specific volume. So we do that both for state 1, which is equal to 2 meter cube per second divided by 0.79 meter cube per kilogram dry air. We get a value of 2.5316 kilogram dry air per second. And the same is done to state 2. And we get a mass flow rate of 7.2674 kilogram dry air per second. So the next thing we'll have to do is to find the values or properties of state 3. So the first thing we will get is the mass flow rate at state 3. And via energy balance, we know that the mass going in, 1 and 2, is equal to the mass going out. And substituting the values acquired, we get a mass flow rate at state 3 of 9.799 kilogram dry air per second. So the next thing we will have to do is to get the uh, dry bulb temperature at state 3. So why do we need to find the dry bulb temperature at state 3? Now, as I've said earlier, you will need one of those thermodynamic properties. It could be the specific humidity, the dry bulb, or the humidity. So, gikan ni sa katong equations nga gipakita na to pag last. So, to, di ba, upat. The first one is for mass. Yeah, the last is for kaning tulo. So, either raning tulo ang gamiton. Now, for the sake of simplicity, we will choose the dry bulb temperature. So, getting the dry bulb temperature at state 3 using this formula. And then we substitute the values. And now we will get a dry bulb temperature of 19.5746 degrees Celsius. So what we will do now is to get the specific enthalpy. Now there are two ways to get the specific enthalpy. Two ways. How? First, via charts. So since we already have one psychrometric property of state 3, the dry bulb temperature, we can get the specific enthalpy at state 3. The other way is via equations. So one of the equations I've shown earlier uses the specific enthalpy. So this is what we will use for this sample problem. So equations ta. And this is the equation as I've shown before. And substituting these values, we get a specific enthalpy of 40.6634 kilojoules per kilogram of dry air. So now is the last step. So before the din halimut ko, i-show pa din ako ang pagkuha sa wet bulb temperature at state 3 at the same time ang pagkuha sa specific enthalpy at state 4. So kani siya specific enthalpy o kaning wet bulb. So continue ta sa katong gipakita nako. So now we know nga ang temperature sa state 3 is 19.57 or ato lang i-estimate, i-round up na to. So 19.6 degrees Celsius. So what we will do is just to get so kuha tag red nga line since mo man ang represent sa temperature, then we go to 19.6. So 15, 16, 17, 18, 19.246. So there siya. 19.6. So di ba usara ka thermodynamic property ang kailangan, thermodynamic na usa ka psychrometric property ang kailangan para makuha ang state 3. So that's how you get it. So atong i-label para dili libog. So this is state 3. So now we get state 3. So how did I get the wet bulb temperature? So, di ba ang kaning diagonal nga green lines po man na ang both for enthalpy and for the wet bulb. So, ato na i-move. So, kung ano to ang sa tumoy lang. Okay. at the end. Move na to sa intersection. So now we can see nga ang iyahang wet bulb temperature is between aning duha, so 15 and 14. So since more siya ka ng more to the right siya sa kung i-kuha ni mga middle, so mo to akong gi-assume nga 14.6. So that's why the wet bulb temperature at state 3 is 14.6. The next is to plot it padung sa state 4. Now, ang naka-state sa problem kay ang dry bulb temperature at state 4 is the same with the temperature at state 2. So, meaning ana, you just have to make a line from your state 3 padung sa kaninga line for state 2 since same temperature mas nanduha. And from that, you now have your state 4. So atong ipabaga ang kuan ang line para makita, and then let's label it. So state 4. And same as before, kuhaon na to ang H4 since kailangan mo na to kuhaon ang enthalpy para maka-energy balance ta to get the heating required. So same gyapon. Itong i-kuhaon ang diagonal. And then we will read the enthalpy. So kani siya kay 45, 46. So it's 46.5 ang iyahang at saturation. And then since medyo layo naman siya sa enthalpy deviation nga 0.2, so i-assume na to siya as minus 0.3. So that's 46.5 minus 0.3, which gives us a value of 46.3 ay point kamura 0.2 0.3 gyapon kay akong gi-minus kay 0.2 ra day. So ano nagdubli ni delete. So dili wala din ako gi-assume as 0.3 day ang enthalpy deviation, gi-assume ra nako gyapon as 0.2. So montong 46.3 kilojoules per kilogram of dry air. So continue ta sa pag-solve. So now is the last step. Now that we are done considering the adiabatic mixing process as shown by this system, we will now take a look at the sensible heating portion. So matod pa, this is mixing, while this one is sensible heating. So duha di siya ka-process di ay sa kaning problem. So to get the heat or the heating that is done, we must have an energy balance. So the energy balance is shown by this one. So same gyapon ni summation of energy going in is equal to the summation of energy going out. Now the thing that we must consider is ang duha ang input state 3 ug heat Q, while only one is going out kanang sa state 4. And since kibaw man ta nga there's only one input and one output of dry air, so the mass of dry air at state 3 is equal to the mass flow rate of dry air at state 4. And let's simplify the equation by manipulating it. And then so gi-substitute nato ang MA3 for the MA4, and then we move this one transpose to the other side to get this equation. And substituting the values, we get that the heating required is 55.233 kilojoules per second. So, mo na ang tulog ipangita sa problem. Heating required, the dry bulb temperature and wet bulb temperature of the mixture after mixing. That is all. Thank you. Sige, so namoy questions. Muna to ang end.
Oro na kay question, same sa ganina kay pwede ra
Mm.
temperature ning kuan sa H4 H3 niyan times specific capacity.
Katong kuan tong CP delta T.
Yeah, times mass.
Ako do i-try daw if same ba ang gawas.
Kay sa katong sample problem kay ganyan na ako but mag-same ra ang nakuha. But i-try daw kung
I-try na ko. Kaning kuan lang kaning enthalpy at 3. So ang question nimo is ay ang pasabot na ko ani is pwede ang imuhang pamaagi if same ang H3 nga gikan sa table og katong CP delta T. So i-try daw na ako daw. So that's CP 1.005 times 19 points. Layo-layo lagi ako makuha, no? Di siya mo abot og 40.
Ang kuan.
Hmm.
Kanang bisag sensible. Gingan ako sa sample problem niya. 32 ako nakuha. 32 kilowatts.
Basig pwede na siya.
Sensible
Pero
heating sad to. Katoy nga ni sad nga process.
ay di, kung sensible heating, okay ra man guro inana kay kuan man na usually ang sensible heating kanang di ba namtoy nakalimot na ko ato pero ang concept is ang change in H under sensible heating is just equal to the change in Q or heat. Ang Q ra ba nato kay mo tong MCP delta T. So mo to duman para sa sensible heating.
So for kanang adiabatic mixing niya, nag-sensible heating, dili to ma-apply.
Feel ko di siya ma-apply.
Okay, thank you.
Okay, I think sa man. Ikaw lang.
Ay katong question ako, for example ba dili siya ma-state sa problem kung kinsa ang kanang first nga condition or kanang
Okay.
TDB1 kay pwede ra mag-assume?
Pwede ra.
Okay. So pwede ra si number si 2 kay ang lower like
Oo, pwede ra.
condition. Okay, thank you.
So, kung wala gi state nga, state 1 ang kaning siya, kaning una. So, depende pwede ra sa imong balihon. So, pwede kaning siya kay 2 na ni siya, nya kani ang 1. Same ra magawas. Pero mo lagi mo to yung mo to ang importante i-plot nang jud nimo para makita ba. Ay, plot na nun kanang i-label ni tarong ba kay basig maglibog si sir nga kani V1 ay like kani example kani TDB1 4 degrees Celsius. Ya inigtan-aw niya inigbutang nimo sa chart kay ang 4 degrees Celsius gi-label nimo as state 2. So dapat mas i-kuan lang like i-show ba nga gikan sa chart og sa given nga same ang duha.
Okay, sige, thank you.
Then ayo kuan day katong sa psychrometric nga calculator na ako'y duha gigamit ang usa kay gi-download na ako kaning psycrocalc pero dila ko mo recommend ani kay freeware mangud siya good so na chance nga virus then if ako kay sure naman jud ko dagani virus sa laptop so wag ko nag-uol pero kung kamo kay I suggest na lang nga internet like na may online guro ya kani ay nindot sad ni siya ang nindot ani niya kaning flycarpet.net nga psychrometric chart kay usually man good ang uban kay usa jud sa kailangan ang dry bulb. So diri pwede nga dew point, pwede specific humidity, nya usa lahi. Kay sample nato usa nga dry bulb ra jud ang first input nya ikaduha kay pwede na either aning uban. So mo ako ma-suggest kani siya.
Kanang ang website iyan na i-plot sa or
Dili niya i-plot, ira ipakita kung asa na nga point sa chart. Like for example, sa to 4 degrees Celsius nya 2 degrees wet bulb. So dili lang siya carrier, ashray maguro ni siya nga chart ang gamit ani. So anong what man ni gawas. Sa kalimot ko check. Inani ra, nara siya mugawas nga inani ba para makita nimo asa sa chart. Pwede niya ma-plot nga katong ang process jud mismo nga state 1 to state 2. Sige, any other questions? I guess wala naman. Okay, that is all. Thank you, everyone.
Thank you, Oro. Napay question, guys?
wala na ko'y question.
Napay question, Anto? Zar? Ice? Asa ka ni sila? Wala na, I guess. Wala na, no?
Ay,
Okay,
nakoy
Zar.
question ka lang.
Sa man
Pwede may mangayo sa PowerPoint na presentation ninyo, guys.
Kwan.
Sa video
I-post
chat
lang.
ni Oro.
I-post sa YouTube. Pag may gamiton ni Sir for mag
I-post ni sa YouTube ang kwan.
Kwan,
Ay.
kanang. Pwede ra i-post diri sa Teams. Kaning nga channel ang katong learning materials nga gigamit.
Okay, thank you. Thank you, guys.
Post lang na to, Des o Oro. Mona. Mora no? Thank you, guys. Kuan di ay, nangayo si naay kuan. Wait ha. Naay kanang evaluation form. joke dili evaluation form ako nakati. Na evaluation form niya. Please lang ko og kuan kanang anyway
Kada
kanang
subject
fill
na,
out.
HR?
I think
Evaluation. Oo, sige, sige.
hindi ko sure. But I think no. Pero kuan lang tanawon no. Kuan ay hindi ko sa day. Thank you Roel. Hindi ko sa day, sorry. Kuan kanang sa ni uy. Oh, mga nayo day si Carlo og kuan kanang photo op sa atong session. So, pwede ta mo turn on camera na screenshot together mode. Ay, ice. Ngayon kag meeting, ice. Uy, ang delete. Okay ra to. Ruba, asumir delete. Sige, go. Asa mo si Anto? Buwa si Anto. Sige. 1, 2, 3, smile. Pwede ra sad. Kung kasi uban nga maka-screen cap, pwede ra sad. Ato isa ni Carlo. So, mara to. Thank you kayo, guys. Thank you, Oro, Dasa, Mel, and Ice, and Anto, and Vincent. Oh, si Vincent! Balik ka na si Vincent. Wala na po si Vincent. Dali, Vincent. Dapat nakakasend. Si Vincent. Sige. Okay, 3, 2, 1, smile.
Thank you, guys.
Thank you.
Thank you,
Sa
guys.
tanan.
Salamat kayo.
Bye-bye.
Bye-bye. Pinana-leave. Ako na ni-end ha. Thank you.